Hello friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 59. In a last video we saw scanner class. In this video we are going to discuss about Java multithreading. So let's first understand what is a multithreading. Multithreading in a Java is a process of executing a multiple thread simultaneously at the same time. Instead of one by one process executing, we can execute a multiple process at the same time using a multithreading. A thread is a lightweight subprocess. One program have a multiple subprocess and we can create a thread for those subprocess and execute those subprocess or we can say execute those created thread simultaneously. Let's consider when we write a one Java program, simple Java program, there we write a main method. That main method is a nothing but thread. That main method is a by default single thread application. When we create a simple application without using a multi-threading concept, that application is the single thread application. But if you want to implement a multi-threading concept, then we have to use a multi-threading concept, or you can say multi-threading classes. We will discuss all this, how can we applicable, how can we implement a multi-threading in our simple application. Okay, let's talk about a real life example. Let's consider here bank. The first image, there is a single counter bank. Okay, and the second image you can see there we have a different counter, three counter, and first image we have a single counter, and every bank perform a operation like a withdraw money, deposit money, check balance, inquiry about a new account, inquiry about a loan application. All this activity happening in a bank. Let's consider there is a single counter and single employee. That bank, there daily 100 people visiting. At the same time there around 7 people visited. This time this bank have a seven customer in a queue. Okay, the first and second customer want to just withdraw money, then third and fourth customer want to deposit, and fifth and sixth customer want to just inquiry about a new account, and this last customer want to just check balance. Let's consider this each customer take a 10 minute. Okay, that means this first 6 person take a 1 hours. Okay, then this 7 person want to just check a balance. For just checking a balance, this person want to wait 1 hours. Okay, that's not flexible for anyone. No one want to wait 1 hours for just checking a balance. It's a 1-2 minute works just checking a balance, but for that this person want to wait 1 hours. Why? Because there is a single counter, one by one execution. Let's consider this one is our program. Okay, this one is our program, and this 7 is our sub processes. Okay, this 7 is our sub processes. Here first process execute, then only second process get chance, then second process execute, then only third process get chance. This first diagram you can see, this one is a single thread application. Without using a multi-threading, this problem we can see. Okay, in a second diagram, here we simply can see multiple counter. Here simply bank have a multiple counter. For each counter have a different activity. The first counter just withdraw money and deposit money, then second counter just check balance, and third counter for a inquiry about a new account, or we can say application, loan application, all these other activity. This last person directly go in a second counter and directly check balance. This last person don't want to wait 1 hours for just checking balance. Also this other person also get a quick chance. Okay, don't need to wait one or half hours or 1 hours for just doing a simple activity. That's the real life example. We can say if interviewer ask you real life example about a multi-threading, then you can consider this example. Okay, just a single counter and multiple counter. Single counter, there each object, each process want to wait more time. Okay, but multiple counter get a simultaneously access for each object, each person, and those quickly perform their operation. Okay, and we can consider one more example. If you visit a train ticket counter, sometime train ticket single counter open and sometime they multiple open counter, depend on how many people in a queue size, how many people want to get a ticket at the same time. Depend on that, they simply increase counter or they simply decrease counter. There is no train coming time, that time only single counter open for ticket, for collect ticket. But there is any express train coming time, that time multiple counter open, because at that time multiple people want to get a ticket at the same time. Okay, that's why they simply open a multiple counter, and then if traffic decrease they simply open a single counter, if traffic increase they simply open a multiple counter. Okay, depend on a situation, they simply increase or decrease counter. Okay, the same thing in a multi-threading also we can perform. If multiple process visiting at the same time, then we can simply increase the thread counter and we can simply decrease the thread counter at a dynamically. Okay, here we discuss a simple multi-threading real life example. Okay, then you can see this gaming application, this four car. Okay, this four car, each car have their separate thread. This thread is not depend on each other. Okay, this first thread, you can see this green car if destroy this, if this thread collapse, if this thread come any exception, then other thread not terminated, only this thread terminate. Okay, that means this each thread not depend on each other, it's a individual, it's a independent, each thread is independent. Okay, so let's, before understanding multi-threading we have to understand a multitasking. So let's first understand multitasking. Multitasking is the process of executing a multiple tasks simultaneously. We use a multitasking for work on a multiple application simultaneously. We can achieve multitasking in a two way. First way is the process based multitasking and second one is the thread based multitasking. So let's first understand what is the difference between process based multitasking and thread based multitasking. Process based multitasking work like a multi-processing, or it's work a OS level. Here we switch one application to another application. Each process have a separate memory area. Okay, let's consider, here we simply open a multiple application. We open a Eclipse, we open a this PowerPoint, we open a video editing application. All this application is nothing but a process, one process, or we can say one separate application. Okay, we can simply switching this PowerPoint to, we can simply switching this PowerPoint to video editing application. Okay, that is nothing but a process based multitasking. We are simply using a multiple different application. Here process based multitasking, in a process based multitasking we are simply using a different application. Okay, those application not depend on each other, those application is a separate application. Then second one is the thread based multitasking, is nothing but a multi-threading. This one is a process or a program level. Here switch inside application thread share the same address space. Okay, here we can simply, here in a process based multitasking is nothing but a multi-processing. Here we simply switching one application to another application. Here we simply switching, the both application is a totally different. This PowerPoint and video editing application is a totally different. We are simply switching PowerPoint to video editing application. Okay, but in a thread based multitasking, here we simply inside the application multiple processing happening. When we write something in a PowerPoint, that at the same time we are writing that one activity, and PowerPoint the recognize the text and it's a spelling correction. One of features PowerPoint, spelling correction, that is another process. Okay, and also the text management, all these thing, multiple process happening inside this one single application. Inside this PowerPoint application there is a sub application, we can say sub processes, multiple sub processes happening. Okay, for those multiple sub processes we can create a thread. We can for writing application, for whatever we writing, for write that content, that is one thread. And when we writing that at same time another one thread running, that thread recognize text and recognize a spelling correction, okay, and it's indicating us this spelling is a not right, this spelling is a wrong, okay, something like this. This multiple processing, multiple operation happening inside a single application, okay. We can simply say process based multitasking is a different application. We can simply switching one application to another application, those two application not linked, not related each other, okay. Those application have a separate memory, everything is a separate, those application not depend on each other. But thread based multitasking here depend on each other, because inside one application we have multiple sub processes. Those sub processes is nothing but a thread, okay. So here we understand process based multitasking and thread based multitasking. Then you can see this one is the operating system, this one is our operating system. This process 1, process 2 and process 3. This process 1, let's consider this process 1 is our PowerPoint, okay. This process 2 is our Eclipse, and this process 3 is our video editing application. This process 1 have a multiple thread. This first thread for writing content, this second thread for spelling correction, this third thread for something scalability, or we can say line scalability. All this three thread inside this single application. Then this second application, okay, process 2. These processes not depend on each other. This process 1 is a separate, this process 2 is a separate, this process 3 is a separate. If we terminate this process 2, then not impact on a process 1 or a process 3, okay. But if we terminate this process 1, inside this process 1 this 3 thread is running, those 3 thread also terminating, okay. Here you can see processes is the operating system. Inside the operating system we have a multiple processes, or we can say multiple application running at the same time, different application. Inside those application running a small sub processes, okay. Those small sub processes is nothing but a thread, or we can, if those not thread, then we can convert those in a thread, okay. Simply remember this operating system. Inside the operating system process is nothing but application, different application. This process 1 is a PowerPoint, this process 2 is a Eclipse, and this process 3 is a video editing application. This process 1 have a different activity. First one is a write activity, second one is a spelling correction, and third one is a scalability, okay. These three activity happening at the same time. Here you can see processes thread 1, thread 2, thread 3. It's have some time limit, okay. Some thread is continuously running, this spelling correction thread is continuously running, this write thread is continuously running. But if we performing a simple one activity, that thread taking some time, that operation, once that operation perform, then that thread automatically destroy, that thread automatically terminate, okay. Simply here we understand what is the threading, where exactly we use the threading, and what is the multi-threading, what is the multi-processing and multi-threading. We saw the difference, and also we saw what is the process and what is the thread, okay. So next video we will see next topic. Till that, bye bye.